Hey guys, this is Parani from Great Learning, and I welcome you all to this YouTube live session on data mining. So, let's quickly have a look at the agenda. We'll start off by understanding what exactly is the need of data mining, and then we'll look at the data mining lifecycle. After that, we'll look at the most important part of our session, where we'll go through some of the most commonly used machine learning algorithms. And finally, we'll be implementing a demo on data mining with Python. All right. So I'll start the session by asking a very simple question. So guys, tell me what exactly is data? So what comes to your mind when you hear the term data? So simply put, data is just collection of facts. So when you work with numbers such as 23, 8,000 or 3.14 or any of these numbers, well, you're just working with data. And when you say statements such as this is Sparta or my name is Jim or my name is Pizza, so these again is data. Now, it's not necessary that data has to be in the form of numbers or text. Data can also be present in the form of pictures and videos. And especially after the advent of social media and technology, most of the data which we have, it's actually present in the form of pictures and videos. And why am I telling you guys about this? And that is because data has gone from scarce to super abundant in the past 3 decades or so. And this is the data deluge that I'm talking about. So, to understand this data deluge properly, let's understand what was the data back then and how is the data today. So, the data back then was small and structured. So, when I say data was small, it was only present in kilobytes. So, it was very, very small. And data was also structured. Now, what is structured data? So when I say structured data, data is mostly present in the form of rows and columns. So it is tidy data. And since the data was small and structured, you did not have anything to do analytics on top of it. But with the advent of 21st century social media and technology, this data has exploded exponentially. Now we've got humongous amount of unstructured data which is present in multiple formats and is also coming from multiple sources. So we've got huge amounts of data in exabytes and petabytes, right? Now when I say unstructured data, as I've already told you, data is not just present in the form of Excel sheets. So we've got data in the form of pictures and videos and multiple other formats. But the real question which arises is, what are we actually doing with this huge amount of data? So you might have heard this quote, data is today's oil, but this data is of no value if you're not trying to find out insights from it. And this is where data mining comes in. So data mining helps us to find insights from this huge amount of data which we have with us. So with the help of data mining, we can use it to increase a company's revenue. We can also use it to understand customer sentiments, or to be honest, data mining can also be used to cure a disease. So data mining is very, very important in today's age. So let's actually look at some of data mining's use cases. So with the help of data mining, we can find fraudulent credit card transactions. So let's take an example to understand this. So let's say you are just sitting at your home and you suddenly receive a message from your bank stating that a transaction has been made for $10,000 where you have actually bought a $10,000 necklace, and also you bought that from New York, but you're actually sitting in India and you've never bought anything over $5,000. So your bank is actually getting a confirmation from you whether you made this transaction or not. So your bank is checking if there's a fraudulent transaction or a genuine transaction. Now, how did the bank flag it off as a fraudulent transaction? So this is where your bank is actually using data mining techniques. So your bank goes through the data where it has all of the list of transactions which you've made in the past, and it knows that you have never made any transaction greater than $2,000 or greater than $2,000, and you've actually never been to New York in your entire life. So with the help of these data mining techniques, your bank was able to understand that this is a transaction which you'll not make normally, and that is why it sent you a message just to find out if this was a genuine transaction or not. And then we've got another use case of data mining. So we can also use data mining to tag our mail as spam or genuine. So I believe that most of you would have a Gmail account, and in the Gmail account you would have the spam section. But how is Gmail able to tag all of those mails as spam? Well, again, the answer is data mining. So what Gmail does is it uses data mining techniques under the hood. So it will read all of the data which is present in the mails, or basically the heading or the subject of the data. And if it finds any text where it has sentences such as "you won lottery," or if there are too many special characters in the subject of the data or in the main part of your mail, then it will flag it off as spam. Right. So these are some interesting use cases of data mining. So now that we've looked at some data mining use cases, let's go ahead and understand the data mining life cycle. So your first step would be to acquire the data, and then you'll go ahead and pre-process the data. Once you pre-process the data, this is the time where you'll head on to the most important part of your data mining life cycle and build some machine learning algorithms. And once you build these machine learning algorithms, you will evaluate the results which have been given by the machine learning algorithm. And finally, if the results come out to be good, then you'll go ahead and show these results in the form of beautiful graphs. Now, let's understand each of these steps in a more detailed way. So I've told you the first step is the data acquisition process. Now, we know that data comes from multiple sources and is present in multiple formats. So what we do is we gather or collect or acquire all of this data which is coming from multiple sources and is present in multiple formats, and we integrate them and store them at a single place. So that single place could be our data warehouse. So we are integrating all of this data and storing it into a data warehouse. Now, once that is done, we'd have to choose our target data, or basically one particular domain of that entire data on which we'd want to build our machine learning models and find some insights out of it, right? So this is where we are acquiring the data. Now, once we acquire the data, we have to make sure that this data is in the right format, or it is actually a proper data set. Now, in most of the cases, in actually 99% of the cases, the data which you acquire is very raw. So there could be a lot of problems with the data set, such as it could have a lot of missing values, it could have a lot of outliers, it could have a lot of anomalies. There could also be cases where the data entries are incorrect or the names of the columns are incorrect. So this is where you use the different data pre-processing techniques, right? So you have acquired the data. Once data acquisition is done, you will go ahead and pre-process the data to convert your dirty data into a proper tidy data set. And two important techniques under data pre-processing would be data manipulation and data visualization. Now, data manipulation helps you to find out quick insights from your data set. So, let's say your manager out of nowhere gives you a huge Excel sheet which would comprise of around 10 million rows and 1 lakh columns, and he asks you to find out all those employees whose age is greater than 50 and that person's salary is greater than $100,000. If you were to manually look at each record and check the age of the employee and the salary of the employee, then that would be a Herculean task. So this is where data manipulation comes to your rescue. So with the help of data manipulation techniques, and if you use languages such as R or Python, you just have to type in one line of code and you'll have your results at your disposal. Similarly, if we take the same example, and if you are trying to find out some sort of insights by just looking at this huge data set with 10 million rows, right, then obviously it would be very difficult to get any sort of insights. Now, instead of just looking at the data set, what if you had built a graph on this data set? Now, it could be a bar plot or a scatter plot or a histogram or any graph, right? So if you just look at this graph, then you will be able to find out insights in a much easier manner. So this is the data pre-processing part. And once you're done with data pre-processing and you have the right data set with you, this is where you will go ahead and build the machine learning algorithms on top of your data set. Now, so machine learning algorithms are basically intelligent algorithms which help us to find out meaningful information from our raw data. And you've got different machine learning algorithms such as classification algorithms, regression algorithms, and clustering algorithms. So when you're further going down into the session, we'll properly understand about what exactly is machine learning, and we'll also understand these different types of machine learning algorithms. right? So we have acquired the data, we have pre-processed the data, and once we have the right data set with us, we will go ahead and build our model. Now, once we build our model will give us some result. Now, you cannot be sure that the result which you've got is actually right. So there is actually a three check process where you start off by checking if the result which you've got is correct or not. Then you will check if the result which you've got is useful or not. And then finally you'll check if the result which you've got is new or not. And once these three parameters have been verified for your result, only then you will use the result, or only then you'll say that the result which you've got, is what you're actually trying to find. So you have done the pattern evaluation, or you basically evaluated your result and you found out that your result is absolutely fine. And once you do that, finally you'd have to represent your knowledge or represent your results. So when you have your results, and if you just explain this mathematical jargon or data science jargon to a layman, obviously he wouldn't be able to understand anything that you found out. So instead of finally depicting a mathematical jargon or the data science jargon, if you were to depict this in the form of beautiful graphs, then any layman would be able to easily draw insights from the from the data science model which you've built. So this is the entire data mining life cycle. You start off by acquiring the data. Once you acquire the data, you pre-process the data. Once the pre-processing is done and you have the right proper data set with you, you go ahead and build your machine learning algorithm. And this machine learning algorithm will give you a result which has to be evaluated. And once you're sure that this result is what you actually want, then you'll go ahead and represent this result in the form of very beautiful graphs. All right. Now let's go ahead and look at some of the data mining tasks. So one very common data mining task is anomaly detection. So I've told you that in a data set there could be a lot of outliers present. Now, what is a outlier? So let's understand this with another example. So let's say you actually go to a bar and there is some sort of data around the income of all of the people who go to that bar. So the average income of all of the people who go to that bar is around $50,000 per annum. But one fine day, Bill Gates suddenly shows up to that bar. So when Bill Gates shows up to that bar, the average income it shoots up. So from $50,000, the average income shoots up to $5 million. So Bill Gates is the anomaly, or Bill Gates is the outlier over here. So when you are dealing with this sort of data, it's very important to find out the outliers and treat them properly. And once the outliers are treated, only then we can go ahead and build our machine learning algorithms. So this is one very frequently used data mining task. And then the next data mining task is something known as association rule mining. So this method is used for finding interesting association amongst different entities. So the perfect example of association rule mining would be the beer diaper syndrome. So very long ago, there was a case study done by Walmart. So they had done a case study on single men. So so they had basically done a case study on single fathers actually. So whenever so most of the times when a single father came to Walmart to buy diapers for their kids, it mostly happened that they would also buy a pack of beer along with this set of diapers. Now, this is a very strange relationship, isn't it? A single father coming to Walmart to buy diapers, and along with diapers, he would also buy a can of beers. Right? So this is the beer diaper syndrome, which Walmart was able to find out with the help of association rule mining. So association rule mining basically helps you to find out if there is any sort of association between different entities, right? So and this is generally used in all of the supermarkets over there, and this is actually used for upselling and cross-selling different items. If you go to a store, you normally see that bread packets are stacked to milk bottles, or all of the medicines are stacked in one section, all of the food items are stacked in one section, right? And all of this is actually being figured out with the help of association rule mining. So these were two data mining tasks. Now we'll head on to the main part of the session and understand what exactly is machine learning. And we'll understand that with this particular example over here. So in this slide, what do you see? What is this exactly? It's a fish, isn't it? And how about this? Well, this too is a fish. And this? Well, this again is a fish. Now, how do you know all of these are fish? Well, as a kid, you might have come across a picture of a fish and you would have been told by your kindergarten teacher or your parents that this is a fish. And your brain learned that anything which looks like this is a fish. And that is how our brain functions. But what if I actually take this image of a fish and feed it to a computer and ask it, what is it? Will it be able to identify that this is a fish? So this is where data mining comes in. So what I'll do is I'll take all of these images of fish and keep on feeding them to the machine until it learns all of the features associated with the fish. Now, what do I mean until it learns all the features associated with the fish? So, a fish would have certain features associated with it, such as it would have two eyes, or it would have gills, or it would have fins, and so on, right? So, all of these features are fed to the machine, and this machine learns these features from millions of images. And once the learning is done, it is given new data to determine how well it has learned, right? So this machine is given the new data and we are asking the machine what is the label of this new entity. Or in other words, what we do is we feed the machine training data first, and once the training is done, we'll give it test data to determine how well the training has been done. And this is the underlying concept of machine learning. Alright, so now that we know what exactly is machine learning, let's go ahead and look at the categories of machine learning. So machine learning can be broadly divided into supervised learning and unsupervised learning. So we'll start off with supervised learning. Now in supervised learning, we have something known as the output variable and the input variable. And the data items actually have a class label associated with them. So we have the output variable and the input variable, and this output variable is denoted with y and the input variable is denoted with x, and we are basically trying to find out how does y vary with x, or in other words we have a dependent variable and an independent variable. So the output variable is also known as the dependent variable and the input variable is also known as the independent variable, and we are trying to determine how would a dependent variable change with respect to an independent variable? And this is what is the underlying concept of supervised learning. Now, supervised learning can further be divided into regression and classification algorithms. So we'll start off with classification algorithms. So classification is the process of predicting the class of a new variable. And you have to keep in mind that when it comes to classification, the dependent variable is categorical in nature, right? So let's take this example. So over here, I have a data set of all of those people who smoke, and I want to know if there's any sort of relationship between people who smoke and is there a chance of them getting cancer, right? So this is my dependent variable where I have two labels, yes or no. So yes, the person has cancer, or no, the person does not have cancer. And the independent variable is yes, the person smokes, no, the person does not smoke. And with the help of this classification algorithm, I'm trying to determine if a person smokes or if he doesn't smoke, what is the probability of that person having cancer, right? So this is how a classification algorithm works. So next we'll head on to the next type of supervised learning algorithm, which is regression. And regression is basically used to find out relationship among different entities. And in this session, we're going to focus at linear regression. So as the name states, linear regression is a specific type of regression algorithm, and it is used to find out the linear relationship among different entities. And in linear regression, your dependent variable is a continuous numerical value. Now, a perfect example for this would be if we are trying to determine if there's a relationship between the age of the person and the salary of the person. So over here, the dependent variable would be the salary of the person and the independent variable would be the age of the person. And let's say if I give an arbitrary value for the age of the person, then I would want the exact salary of the person, right? So over here, X. So let's say if I feed in the X value to be 28, which is the age of the person, I would want a particular value for salary, right? So if I, let's say, feed in 28, then the salary needs to come out as maybe 1 lakh INR, right? So this is how a linear regression algorithm works. Now we'll head on to the next type of machine learning algorithms, which is unsupervised learning. So in supervised learning, we saw that there were independent variables and dependent variables, and there was also a class label associated with the data. But what happens in unsupervised learning is we have input data, but there are no class labels associated with the data. That is, we just so if we just look at this picture over here, then we just have images of cars and cycles over here, but there are no labels indicating that this is a car or this is a cycle. So what we'll do is we'll take this set of input data with no class labels and we'll feed this to an unsupervised machine learning algorithm. And this unsupervised machine learning algorithm is basically a clustering algorithm. So this algorithm takes in this data and divides it into two clusters. So the first cluster would comprise of only the cars, and the second cluster would comprise of only the cycles. Now, one thing to note over here is this unsupervised learning algorithm was able to divide this entire data into these two clusters, where one cluster had only cars and the second cluster had only cycles with no input labels associated with them. And this algorithm was able to do so by understanding the underlying structure of this particular data. So if I take this cluster over here, you have to understand that these data points are very similar to each other. That is, there is very high intra-cluster similarity, right? So these cars are very similar to each other. And again, if I take this cluster over here, all of these cycles are very similar to each other. Again, so there is very high intra-cluster similarity. But if I compare, so let's say this is cluster 1 and if this is cluster 2. If I compare cluster 1 with cluster 2, then there is very high inter-cluster dissimilarity, right? So these so data points from this cluster and data points from this cluster are very dissimilar to each other. And all of this we were able to do by using this unsupervised learning algorithm. Right guys, so these are the basics of data mining process, and we've properly understood what exactly is machine learning and looked at the categories of machine learning. Now it's time to do a demo and implement all of these different data mining techniques. So I will head on to Jupyter notebook over here, and I'll open a new Python 3 notebook. So we'll be actually working with the iris dataset. So let me load up the dataset, and before I do that, I'll actually go ahead and load the required libraries. So I'll type in import pandas as pd. So pandas is a Python library which is mostly used for data manipulation purposes. So now that I've loaded this, let me load up the file which I'll be working with. So I'll type in pd.read_csv, and inside this I will give in the name of the file, which is iris.csv, and I will store this in a new object, and I'll name that object to be iris. Right, so I've got my data set stored in this new object and I've named that object to be iris. Now I will have a glance at the first few records of this data set. To have a glance at the first few records, I'll use the head function over here. So the head function would give me the first 5 records which are present in this data set. Now, similarly, let's say if I want to look at the first 10 records of this data set, I'll just put in 10 instead of 5. Right, so what I'm doing is I'm basically performing the basic data manipulation tasks over here. Right, so my first task was data acquisition, where I have acquired the data. After that, I'd have to do the data pre-processing, where I'm understanding the structure of the data. Right, so I have looked at this. So we see that there are 5 columns in total. So this data set is basically about the iris flower, which has different species. So it has the setosa species, the versicolor species, and the virginica species. And these are the different features associated with these different species of the iris flower. So we have the sepal length, sepal width, petal length, and petal width associated with the iris flower. Alright. Now I will go ahead and perform different data manipulation app operations over here. So let's say I want only those records from this entire data set where the sepal length is greater than 5. So let me do that. I will start off by giving the condition over here. So I'll give in the name of the data frame, which is iris, and I'll give in these parentheses over here and given the name of this column, which is sepal length. You'd have to keep in mind that you give the correct spelling over here and also take care of the capital letters over here, right? So if you don't do that, you'll get an error. Now I want only those records where the sepal length is greater than 5. So iris sepal length has to be greater than 5. Let me click on run and let's see what do we get. So we get a bunch of true and false values. So what does this mean? So we get a true value wherever this condition has been satisfied. So iris sepal length is greater than 5. So see that sepal length of this iris flower is greater than 5, and that is why we have a true value over here. So after that we have four false values following, and that is because all of these four values 1, 2, 3 and 4, these values are not greater than 4. These values are not greater than 5. So wherever this condition has been satisfied, you get a true value, and wherever the condition has been not satisfied, you get a false value. Now that I've given the condition, I want only those records which satisfy this condition. So again, I will give in the name of the data frame. I'll follow it up with the parenthesis and give this condition inside this. And I will store this in a new data frame and name it as iris2. Now I'll have a glance at the head of iris2. So I'll type in iris2.head. So as you see, this is our new data set, and we see that for all of these records of the sepal length column, it is greater than 5, right? Quite an interesting observation. Now similarly, if I wanted to create a new subset of this original data set where I wanted the petal length to be greater than 2. So again, let me perform the command. So I'll type in iris, and inside this I will give in the name of the column, so petal dot length, and this has to be greater than 2. Now I've given the condition. Let me copy this over here and paste this inside it, and I will again store this in a new object, and I'll name that object to be iris3. Now I'll have a glance at the head of it. So iris3.head. So let me look at the petal length column. So if you have a glance at all of the records, you'll see that all of the values are greater than 2. Right. Now I can also give multiple conditions at the same time. So if I wanted only those records where the sepal length is greater than, let's say, 6, and also the sepal width is greater than 3, right? So let me go ahead and give in that particular command over here. So I'll give in the first condition. So that would be sepal length is greater than 6. Let me copy this condition and paste it over here. After that, I'll give in the AND operator, and I'll give in the second condition. So the second condition is the sepal width has to be greater than 3. So let me put in single quotes over here. I'll give in the name of the column, which is sepal width, and this has to be greater than 3. Right, so my first condition is sepal length is greater than 6, and my second condition is sepal width is greater than 3. And let me go ahead and cut this out, and I'll paste this in the iris data frame again, and I will store this in a new object, and I'll name that object to be iris4. Seems like we have an error over here, so this has to be capital L and not small l. So we've got iris4. Now let me have a glance at the head of iris4. So iris4.head. So yeah, so if we look at the sepal length column and the sepal width column over here, so we see that the sepal length for all of the records, the values are greater than 6. And the sepal width for all of the values, it is greater than 3. Right, so both of the conditions have been satisfied. So in the data pre-processing phase, we have also done the data manipulation part. Now it's time to do some data visualization part. So to perform data visualization, we will go ahead and use the matplotlib library. So I'll type in from matplotlib, I'll be importing pyplot, which is basically a sub module of the matplotlib library, and I will import it as, let's say, plt. So from matplotlib, import pyplot as plt. We seem to have an error over here. From matplotlib, import. Okay, so this is pyplot. Right, so guys, you have to be extremely careful of the spellings which you give when it comes to the library names over here, else Python will throw you an error. All right. So I have loaded the library. Right. So yeah, now it seems like there are some questions posed by you guys. So let me actually go through those questions. All right, so the first question seems to be, what is the difference between data science and big data? So this is a common question which is asked by most of the students, and the answer is this. So big data is actually any sort of data which cannot be processed by your traditional systems, or your traditional RDBMS systems. And big data is mostly denoted by four V's, which is velocity, variety, volume, and veracity, right? So in today's 21st century, we have this huge amount of data, which basically denotes the volume, and it has a lot of velocity, right? So this huge amount of data is coming at an incremental pace. And also we have, so this data is present in a lot of variety. So we've got structured data, unstructured data, semi-structured data, right? So we've got a variety of data present with it. So this is what is known as big data. And when it comes to data science, the answer is pretty simple. So we are basically trying to find out insights from the raw data which we have. Now, the data science techniques can be applied to any sort of data irrespective of the size of it, right? So data science techniques can be applied to maybe megabytes of data, terabytes of data, kilobytes of data. So irrespective of the size of it, you can apply these techniques to any sort of data. Right, so now let me go ahead and look at the next question. So is decision tree a type of classification algorithm? Yes, a decision tree is a type of classification algorithm. And since it is a type of classification algorithm, it comes under supervised learning. So decision tree is basically a tree-like structure. And what you do is you basically have you basically check for some questions at each particular node. And at the final node, you have the class label associated with respect to the data point. So this is how a decision tree works. Right. So that was actually a brief intro to decision tree. And if you want to know more about decision tree, we'll be actually coming up with more set of videos on data science and machine learning. So do stay tuned to Great Learning. All right. So we were focusing at the data visualization part of it. So I've loaded the matplotlib library. Now what I want to do is I want to make a scatter plot between the sepal length column and the petal length column. So I want to see if there's any sort of relationship between the sepal length and the petal length of the iris flower. So I'll just type in plt dot scatter, and what I'll do is I will map sepal length onto the x-axis, so iris, and this is sepal length. So let me just select sepal length over here. Let me remove the caps lock. Right, so I map the sepal length onto the x-axis. Now similarly, I will map the petal length onto the y-axis. So I'll type in iris, and this would be petal length. All right. So now that I've done this, I'll just type in plt.show. Right, so it seems as if there's a linear relationship between sepal length and the petal length of this iris flower. Now to make it more obvious, I'll add the x-axis label and the y-axis label. So to add that, plt dot x label, and the x label would be sepal length, and the y label would be plt dot y label. So I'll just type in petal length over here. After that, I'll give in the title. So plt dot title, and I'll set the title as sepal length versus petal length. Let me put in quotes over here, and cut this out and paste this again inside the quotes. All right. So now I have given the x-axis label, which is sepal length. I have given the y-axis label, which is petal length, and I've given the title, which is sepal length versus petal length, right? So as I've already told you, it seems that there is sort of a linear relationship, a positive linear relationship between sepal length and petal length. So if the sepal length of the iris flower increases, then there is a very good chance that the petal length of the iris flower would also increase. All right. So this was the data visualization part of it. Now, finally, since we've done data manipulation and data visualization, we will go ahead to the machine learning part, which is the most important part of the data mining lifecycle. So now what I want to do is, if I am given the sepal width value, I want to predict the sepal length value. So I'll be building a linear regression model for sepal length and sepal width. So sepal length would be my dependent variable and sepal width would be my independent variable. I'll just repeat it again. So the problem statement is this: if I am given the sepal width value, I want to predict the sepal length value. And since both are continuous and also my dependent variable is continuous, I'll be using a linear regression model where sepal length is my dependent variable and sepal width is my independent variable. Right. So my first task would be to divide the dependent variable and the independent variable. So I'll type in y over here, and from the iris data set, I'll just extract the sepal length column. So let me type in sepal length over here. Right, so I am storing sepal length into y. Now similarly, I will go ahead and store sepal width into x. So let me type in sepal width over here and let me store this into the object x. Alright, so I have my dependent variable and my independent variable ready. Now it's time to divide this data set into training and testing sets. So as we had seen in the theory session, first to train the model, we would have to give it some example data. And once the training is done, we will give it new data to test how well the machine has learned. So I'll go ahead and divide this data. So to divide the data, I'll be using the sklearn library. So I'll type in from sklearn dot model evaluation. So let me just type in model evaluation. I'll be importing train test split. Let me just rename this properly. So this is sklearn. Let me just wait till this loads up. Learn dot. So this is actually model selection and not model evaluation. Right, so from sklearn dot model selection, I'll be importing train test split. Right, now I will use this method over here and I will pass in the dependent variable and the independent variable inside this. So now this function basically gives me 4 objects, which are xtrain, and then I've got the xtest. After that I've got the ytrain, and then I've got the ytest over here. So this xtrain is basically the training set for our independent variables. Then we've got xtest, which is the test set for our independent variables. Then we've got ytrain, which is the training set for our dependent variable. And then we have the ytest, which is the test set for our dependent variable. So we've got all of these 4 objects over here. And now I'll go ahead and build the model on top of the training set. So let me just, for this, I'd have to go ahead and import the linear regression algorithm. So again, I'll type in from sklearn dot linear model. I'll be importing linear regression. So now that I've imported linear regression, I'd have to create an instance of it. So I'll store that in LR. And I'll use linear regression again, right? So I have just created an instance of linear regression algorithm, and with the help of this instance, I can fit the model on top of the train set and predict the values on top of the test set. So to fit the model, I'll type in lr.fit, and I will give in the train data set, which is basically present in xtrain and ytrain, and I'll just click on 1 again. So we have successfully built the model on top of the train set. Now it is time to predict the values. So to predict the values, I'll type in lr.predict, and I would be predicting the values on top of the test set, which is basically xtest. That is the test set of the independent variables over here. So now xtest basically comprises of values. So x is sepal width over here, right? So basically the training data of the, so basically the testing data of the sepal width column. So this is what we are predicting the values, and when we predict the values, we'll get this, right? So we have trained it on these two. Now when we are predicting it, we are testing it on the test set of it, and then we will go ahead and predict this. And let's say I will store this in a new object, and I will name that object to be y pred. Now let me have a glance at the actual values and the predicted values. So the actual values are present in y test. So I'll just put in y test dot head, and the predicted values are present in y pred, which is actually a numpy array. So I would want the values going from 0 to 4. Right. So these are the actual values of the sepal length column, and these are the predicted values by this model which we've built, right? So the actual value is 5.7, which was predicted to be 5.9. The actual value was 6.2, which was predicted to be 5.89. Then we've got 5.1, which was predicted as 5.753. Now, as you see, there is an error in prediction. Now, whenever you build a machine learning model, there is a very good chance that you will not get a perfect accuracy. There is always some error associated with the model which you built. Now, these are actually errors associated with each particular data entry. So to find out the absolute error, there is something known as mean square error. So let me go ahead and load that from sklearn.metrics. I'll be importing. So I would have to import the mean square error over here. Now that I've done this, I will pass in the actual values and the predicted values inside this. So the actual values are present in y test, and the predicted values are present in y pred. And the final error which is present over here is 0.51. All right, this is the final error in the model which we've built. All right, guys. So this is the entire data mining lifecycle which we have implemented in Python. Right. So this also brings us to the end of the session. Now, before I sign off, I'd actually go to the Great Learning website over here, and I'll just guide you through the BABI course. So let me just open up the BABI course over here. So if you guys are actually interested in doing an end-to-end post-graduation course with the best faculty members in the world, so not just in the country. So if you want to do a post-graduation course with the best faculty members who are present in the world, then you can just go through the PGP BABI course by Great Learning. So as you see over here, this is the #1 analytics program in India, and the faculty members are the best out of the world. So let me just guide through you this program, right? So if you look at the faculty members, you've got Dr. P.K. Vishwanathan, who has a PhD from Madras University. Then you've got Dr. Kumar Muthuraman, who has a PhD from Stanford University. And then you've got Dr. Abhinandan Sarkar, who also has a PhD from Stanford University. So you've got world-class faculty who will be teaching you all of the data analytics and the data science concepts over here, right? And we also provide career support once you're done with this PGP course. So guys, if you're interested, do comment down in the video below. So we'll immediately reach you out. And also, if you have any doubts or queries with respect to these YouTube live, also do comment below in the comment section. We'll be there. We'll reply to you as immediately as possible. So also I'd like to tell you that Great Learning would be coming up with a series of high quality tutorials on data science, machine learning, and computer vision. And also there'll be one YouTube live every week. So please do inform your friends, please do inform your fellow colleagues who want to enter into the field of data analytics and machine learning, because we'll be coming up with these high quality tutorials every week on a regular basis. So guys, this brings us to the end of the session. Thank you and happy learning.